Okay.
Did Randy have something to say as well?
Yeah, there were quite a few items that he wanted to talk about.
Okay.
But he's giving a presentation to RASC Edmonton at the moment. So he will join us as soon as he is able.
Okay.
See if I can find that list. There we go. Yeah, he found some pictures of the Mars occultation. He wanted to mention the bylaws, the email that was sent out. If Chris Gainor's with us tonight, yes, he is. He was hoping he could tell us how the Artemis mission has ended. And he also, Randy also wanted to take an opportunity to remember Dave Bennett.
All right. I can do my presentation another night if you want to do it that way.
Well, we'll
Yeah.
see how it goes.
I can delay as well because I don't
it-
have a lot of information yet on the conference. So
Well, we don't even have Randy yet, so I think
Yeah.
why don't we get going? Let's start with the short ones. It sounds like Dave and Jeff, and then there's probably time for Joe, and then when Chris, or sorry, when Randy gets in. Does that make sense?
yeah, I think that's good.
Should we give people a few minutes?
Yeah, I guess so. When do we potentially start earlier times? Not for a while, right?
That's going to start in January.
Okay.
Oh, okay. So not this year.
There's one
Okay.
more Astro Cafe at the old time, and then the next one after that will start at 7, and we'll see how it goes.
Excellent. Well, why don't we get going then? Welcome, everybody. It's Astro Cafe for RASC Victoria for December 12th. And we have a few people lined up tonight that have some subjects to discuss. And I think, why don't we kick it off with David Lee, and you can get us rolling, and then we'll.
Sure. Let me just share my screen here. I need to bring up one thing first. How is everybody tonight? Everybody keeping busy?
Very busy.
Well, you notice I'm not there in person. I'm ill.
Oh,
Oh, okay. I was wondering whether people were coming down with things. It sounded like a whole bunch of Victoria was sick. So
You don't want to share, Chris?
I figured you'd appreciate it if I didn't.
all right, so I'm going to share now.
Yeah, somehow I came down with a cold like first time since COVID started, and I have no idea how.
Okay, so I was quite busy last week. From about Thursday on, I attended. I guess they were almost full day sessions. They were like from 8:30 to 4:30, except for Saturday. The Astronomical Society of the Pacific is they're primarily focused on public outreach, so maybe even more so than we are. So they're basically, I would say the majority of them are educators, so they're pretty serious about their outreach. But what really impressed me, there are a couple of points that I'll make, and I'll probably give more kind of detailed reports, as I get the proceedings. The proceedings haven't been printed yet, and I haven't had access to the presentations that I didn't actually go to, because they had plenaries and they also had specific talks. So anyways, I was very interested in the fact that they put a lot of stress on diversity and also citizen science. So I'll have a lot of kind of ideas coming back from them on sort of citizen science that we can do here in Victoria. So a lot of talk about the eclipse, the upcoming eclipses. There's an annular and also a total coming up. So there's a lot of talk about preparation for that and how to sort of engage the local vicinities, preparing them for the onslaught of people. I also didn't realize how much kind of free resources there were actually for educators. There's a textbook called OpenStax, which is used for teaching general astronomy, and it's totally free. There's a lot of sort of videos that are based on OpenStax, and I haven't really researched it a lot, but it looks like it might be a good fit along with things like our new NOVA program from National. That might be a good fit for introducing kind of specific topics for the beginners group. The nice thing about OpenStax is the program is kind of splittable. So if there was a particular topic that the group wanted to learn about, you could sort of just peel away that one module. So it's actually quite useful in that way. There was a lot of talk about the mentorship of students as well, which I think we probably need to do a lot more of here in Victoria. So they were also talking about historically underrepresented groups as well. A lot of kind of active learning strategies, like in other words, instead of just hearing people talk about things, we actually do things. So that was very heartening for me as well. And as I mentioned, NASA's Citizen Science program was actually way bigger than I actually thought. But there will be things when I start talking about citizen science that you're going to be familiar with, and some that even I wasn't familiar with. So we'll be introducing that in the new year. The other thing that I found really quite interesting was there was a representative from the Vera Rubin Observatory, and I mentioned this to Reg recently in a phone call, but I didn't realize, like, I knew what their mission was. I knew the fact that they were going to be collecting these surveys, which were very rapid. Like they would only take place like over the course of maybe 3 to 4 nights, and they would have a full survey, right? And they would be doing this for at least 10 years, I think, to get, a lot of data. Well, their other initiative is actually to have a public-facing portal into the data. So there is every intent to, like, once they start collecting this data, to make it available to everybody, actually everybody in the world. So that's pretty exciting. And I looked at some of the module. Yes?
You have your text file in front of your slides.
That's not my slides. This is just that's just a website. There's nothing
here. Website in the back.
Yeah, it's playing in the back. Yeah, so these are just bullets I pulled out. I don't really have a formal presentation.
Sorry.
Yeah, these are just notes for me. So the other part was the portal that they've actually built, and I actually signed. You do have to register, but I signed on as an educator, and it was just fascinating, all the prepared portals into data that are going to be coming out of the observatory. So it's pretty exciting. RASC also made a presence there. Charles Ennis was there to present his World Asterism project, which was wonderful. Samantha Jewett was also there talking about the robotic telescope and the new NOVA program that's going to be launched or is about to be launched. So yeah, quite interesting. And in terms of inclusivity, I was totally surprised that people were attempting to do astronomy for the blind, but they are. And I had forgotten, actually, there's a lot of stuff in the accessibility movement inside of technology, which I didn't even think about. But for instance, for people that are blind, when they're viewing material through a browser, in actual fact, like actual images actually have alt tags on them. So they can have actually full audio descriptions of the actual image that you're looking at. And I thought about the skill sets that are required to be a good science communicator. And boy, the teams that they're talking about are extremely diverse. Like there's room for people that are really good with graphics. people that are understanding of the concepts, the physical concepts. And actually, I was quite moved by the fact that they said that it was really important to perhaps even have a poet do the descriptions of the images. And I thought about it afterwards, and I thought, well, if you can't see, all you can do is feel the spirit of the image through description. So kind of obvious, I guess. You kind of need somebody who's really good with words. So the other thing they were also talking about was how astronomy / science could actually improve the lives of people around the world as well, like as a sort of a broader movement, part of the One Sky movement. And yeah, so that plus all sorts of frameworks for science communication. So this is like kind of really quite exciting for me. Their movement for doing science communication was very large scale. So I'm going to be pleased to maybe present some of the material that I learned about in citizen science in the coming months. So is there any questions about what I just mentioned? Okay, so if you're interested, I mean, we are going to start up citizen science in the new year. So if you're interested, just let me know, and I'll sort of include you on the inaugural list. But I think I'm going to try to get people involved with it, if they join the group or not, just to present maybe some projects that we could do as a community. Anyways, thanks.
Thanks, David. Jeff, I think, had something to speak to.
Yeah, thanks, Brooke. I just wanted to make everybody aware about a play that's coming. You may be aware of Langham Court Theatre. They closed about a year ago under accusations of discrimination. The board resigned. They have reemerged and they're starting their new season. The second play that they're presenting is going to be called Silent Sky. Silent Sky is about Henrietta Leavitt, who is an astronomer at Harvard at the early part of the 20th century. She's the gal that recognized the variable stars for the first time. And the thing that twigged me about that was we'd talked about the Glass Universe earlier this year, which was a book about the Harvard researchers, and she's prominently featured in that. So it should be interesting to see how they deal with that. That play is coming up in late July to February. And I'll just post the information about the Langham Theatre in the chat log. So that was just what I wanted to mention, Brooke.
Thanks very much, Jeff. Okay, so I guess Joe could probably take over, and he's got some. Oh, Margie has a question.
I just thought that in terms of Langham Theatre, that play was supposed to happen before COVID. And we had talked about, at that point, connecting with Langham Theatre and having telescopes outside.
So Margie, are you thinking we
idea.
should maybe reactivate that idea?
It might be an idea. Mm-hmm.
It's definitely an idea. That's pretty cool. Let's Margie, do you want to talk with me later on about a strategy for talking to them?
Sure.
Where is the theater?
Right. It's very close to here. It's in Rockland.
It's near Pemberton and near Government House.
Okay.
I met with them just before COVID when the things were getting set up, and I went to Langham Court and we thought where we could put telescopes up and this sort of thing. They were quite open to it at the time.
Oh yeah.
Interesting idea.
Yeah, so I've posted the information now in the chat. They're in Langham Court, but they're actually not that far from where you guys are now at the meeting house.
Oh, Jeff, have they changed their location?
I don't think so.
Oh, okay, same place.
Mine's still up.
And when is that supposed to be on?
They start late February. They talk about the play being January the 25th to February the 11th.
Oh, so that's not prime observing season.
There may be some spots for the moon though.
Mhm. Perfect. Are you all ready to roll, Joe?
I am.
Excellent.
Forgive me, I'm just doing two things at once here. Okay. So, Randy and I have sort of been watching a dumpster fire happening on social media surrounding astronomical images, or one particular image of Saturn, as it turns out. And the subject came up about maybe we should have a look at discussing astronomical images and whether people think they're real or fiction. And so I thought, well, let's just pull a few things together and ask some questions of the astronomers here tonight. This is the image in question. It's a beautiful image. The problem is, part of it is fake. The person who posted this on Twitter and other social media made some pretty bold claims. And as it turns out, he hand drew most of the rings, especially the outer rings, and made claim that it was an image that he took when really, yeah, he did take some images, all right, but nothing that would yield this. I mean, he claimed this came from a 12-inch telescope, earthbound telescope, and there's just no way. And so I just posted his text here so you could read it, and it'll be part of the recording, so you can come back and have a look at it if you want to and follow up. But I think the reaction from Christopher Go, who's a planetary imager based in the Philippines and quite famous, was called him out on it, of course, and he got quite upset and made all sorts of accusations, and I don't know. It's Damien Peach piled on, and some other people piled on as well. However, this guy called Tom Williams actually analyzed the image, and he proposed all sorts of explanations. As you can see there, they're itemized 1, 2, 3. I'm not going to go through it all. But as I said, my interpretation of all this kerfuffle is that he just drew in what he wanted to draw in, especially the outer rings, outer ring detail, because there's no way you can get that. There's anyone who's done planetary imaging.
They were basically just highly edited. Is that what you think, Joe?
Yeah. Tom talks about some kind of what did he call it? Some kind of vertical, stretched vertically. That makes no sense to me at all.
So
It was just drawn in, basically. Yes.
I think if I understood, he took one segment of the ring, and then he's rotated it all the way around. And so some of the detail is noise that looks like signal because it's coherent all the way around.
Yeah. That's right. That's another way of saying he drew it in.
You know, I think it would be fine as long as he didn't claim that it was of any standard techniques and that maybe it was purely illustration, which I think is.
Yeah. And if you
all right,
read
as long as they say
Tom's last sentence on the screen I'm showing right now, that's exactly what his point was as well. And that's exactly what should be happening.
Mhm.
Yeah, absolutely. So anyway, that is that's what sort of got us here. But I'm a little more generous probably than some of the famous planetary imagers, and I would just say, yeah, this guy's got some fake imagery, and it's not the first time that's happened. It won't be the last. And he's making a bit of money from it, and fair enough, whatever. He's not proposing that he's a professional astronomer, and it's not being used for scientific purposes. So I would just let it go, but that's just me.
How is he making money from it?
Oh, he's just selling it as a screensaver. I don't know how the heck he has a small online business. You can look it up. The Vast Reaches, it's called. People monetize these images all the time. And you know, Christopher Go and Damien Peach do the same thing. They either sell the images, or they sell their processing techniques, or they sell exclusive club privileges. You know, they're doing the same thing, but I don't care. This guy just happens to be selling the image itself that is fake.
Well,
Anyway,
it's not only fake, but he's misrepresenting it as well.
yeah, and that's the thing that got everyone upset for sure. Yeah, he definitely tried to string people along, and as you can see in his note on the bottom right corner there, the Vast Reaches thing, you know, he didn't dope his data and all this sort of stuff. So whatever. Life's too short, says the 70-year-old. Move on. So what I wanted to discuss actually was, well, what about everyone else in the group here, especially tonight, who's here looking at this thing? Do you think this image of Io that was created by a very reputable organization called NASA JPL, do you believe it's real?
And
they're
was
always
on,
very.
and was on APOD the other day.
It was, and since they were fooled once, they're now doubly careful of what they post. So yeah, I tend to believe it. It's certainly a genuine image.
It's not so obvious.
But you know, the coloring is so bright. I was kind of wondering. And so I had a look at this is a Galileo image, which is a fairly old mission. This is actually created by combining 8 filtered band passes. For those who are into the technical aspects, it's between 350 and 1100 nanometers wavelength. That, as it turns out, is pretty close to the sensitivity of the human eye, because we can see roughly 380 to 800 nanometers, give or take. So I poked around and I got another image, a beautiful image of Io. And I inserted that in the bottom right corner there, along with the other images in that set. This is from the Long Range Reconnaissance Imager, which is a more recent image, or more recent mission, the New Horizons image, or mission, I should say. So Laurie is a different approach. This doesn't use any color filters or any filters at all. It produces a panchromatic image, but it does produce it over a wide band with bandpass as well, 350 to 850, which almost exactly matches human vision. So both images could be considered human natural images, natural colored images. I mean, obviously one is monochrome and one is color. But what do you think? Do you think do they look real to you? Do you care?
Well, to me, I mean, we're quite used to kind of what we call false palette now. If we're kind of looking at features, I don't see there's a problem with that. To me, if I wanted to sort of capture, quote, real physical light, I would want to look at a standard of some sort, use filters of appropriate values, and then see if I can deduce that that's exactly what I would see. Like I would test that concept. I know a lot of people that do narrowband work. It's just often done to taste, right? It's often done choosing colors that maybe emphasize a certain level of detail. But what do you think, Brock?
Well, I think as long as it's using real data, as far as the detail and color, it's all about what you're saying. Like if you're saying this is IO in true color, then you better back that up and you better have some reasons why that makes sense. If it's IO and I'm trying to emphasize the difference between iron being excreted from the core versus sulfur or something, and you're trying to bring out that color and enhance that, as long as you're saying that I've split these out and done something to enhance it. It's same as doing the Hubble palette that's done for a reason to separate sulfur from hydrogen alpha, and it helps to actually understand what's happening in a nebula, and no one's saying that this is what it would look like if you could see it. And the thing is, we can't see them anyways because our eyes aren't sensitive enough. So I think as long as you're being honest with people and you say, I took this picture and I mapped it in this way to illustrate a certain thing or to emphasize a certain appearance, then I think it's good. I think, it looks like that Vast Reaches or whatever that knucklehead is, it looks like he stole the rings from Hubble from what I could see. But
well, that was Christopher Go's proposition, and he had to retract that because once the other guy chimed in and actually analyzed it, they realized that was not the case.
Well, it could be that he was inspired.
It was worse than that.
By...
He didn't even use Hubble.
Yeah,
you got to be really careful when you say. I mean, there's a difference between art and an accurate picture. But your eyes are playing tricks on you too. Your brain is playing tricks on what the eye sees. Like you see that's yellow, but I don't actually have a receptor in my eye that perceives yellow. What I'm seeing is a mixture of red and green. I don't know if it's a mixture of red and green. I just see that as yellow. But yellow light is different than a mixture of green and red, for example.
And in actual fact, David, your eyes are not the same as mine either, for that matter.
But to me, it looks like, in terms of brightness, it looks very much like the picture on the left. It looks, if you take the yellowness away, it looks very much like the picture on the left below.
Yeah. That's right.
A couple of people have mentioned it, but I think the line that gets crossed is when it's misrepresented, especially for monetary reasons. I mean, you can do art of it also, as long as you call it art.
I'm going to cover a little bit of that at the end, but you're right. That's exactly what can happen. And people can use other methods to create planetary images or other celestial images.
I have questions about the whole concept of true color. I grew up in a household where my father was totally colorblind, and so some of the descriptions of things that he described as colors that I just never saw. So,
Right.
and as Joe says, everybody's eyes are slightly different. So it's, you know, to say something is true color, I just think that's a null statement. I don't think that can be true. There is no such thing as true color.
Yeah.
Okay.
So I'm just going to quickly highlight a couple of things that I have done, because I come from an image analysis background, mainly from using Landsat imagery, which is a satellite imagery of the Earth's natural systems.
Joe, do you mind answering a couple of questions? There's John
Sure.
and someone in the actual on-site meeting, and also Chris has questions. So,
Okay, I don't seem to
John,
be
do you
able
want
to
to?
get to the chat. Maybe you could just read it to me.
I just want to make a comment. I agree with many of the things that have been said already about the images, but there is one thing that goes on in the media that really bothers me that's related to this a bit, and that's there are all kinds of programs on television and whatnot where no distinction is made between images that are artistic impressions and images that are actually taken of objects.
Yeah.
And I think that's really misleading to people. Brock's comment comes to mind here. I mean, if you're honest about what you're showing and just tell people what you're doing, that's fine. But if you make it look as though, you know, an artistic image of something that you've drawn is actually reality, I think you're really misleading people, especially young people.
So
absolutely right.
I'm the one who put the hand up from this room. Every day, as several people here know, I put up an image of the moon in Enkin's Daily Moon on Facebook, and I just want to talk about Brock's criterion was, is there any fake data? You know, it's okay as long as it's got real data in it. But the thing that some people do, and I will not put on Enkin's Daily Moon, is where they put the moon in a picture where the moon ought not to be. There's lots of pictures of, you know, saying, this is this amazing view from the Arctic, and you see the sun and the moon together, you know, full moon and the sun at the same time. It drives me absolutely crazy. So it's not that it was real data, but it's a you know, superposition. So it's got to be something. Your criterion, Brock, is correct, but it's missing some element of it, which I don't know how to word.
Yeah, well, it's a misrepresentation of what can physically happen. Like, obviously, that doesn't make any sense if you have a moon, full moon next to the sun.
Deliberately misleading people. Yeah.
Yeah, and it doesn't go. It doesn't go towards trying to help people understand why the full moon is a full moon if the sun and moon are seen next to each other. Just
and as people know, I have nothing against artistic pictures. I love paintings of the moon. As long as an artist says, this is the moon, I will put up almost anything. But it's when they say this is a real picture, when it doesn't work, that I won't put up.
Yeah.
I've gotten to be known as something of a wet blanket on a couple of the Facebook groups that I'm on. People post a lot of pictures that are just absolutely gorgeous pictures, but they label them as being something else, as a picture from the Hubble or something. And I feel bad saying, look, it's beautiful, but it's not what it says it is.
Mm-hmm.
Yeah, I'm afraid
Chris?
I do the same thing.
Yeah, I have basically a couple of comments too. If you look at my book about Hubble, you'll find that there's a discussion of practically this very topic, because there have been controversies in the media about
that the Hubble pictures are faked and all this sort of stuff, for example, the Hubble palette is using kind of different colors than one might use if you were really religious about, what would you be seeing if you were parked off a certain object in the Starship Enterprise. And but of course, practically all images we see are not necessarily what you would see in nature. For example, the pillars of creation, one of the great powers of that image, or one of the features of that image, is that it's edited. Usually when we take a picture of it, it's or produce an image, it's the whole works. We don't sort of cut it down to that little bit in the middle. And also, the very act of using a telescope is in effect a distortion, because it's collecting light. And then of course, you get into time exposures and all this stuff. It goes on and on and on. But anyway, I don't think I really need to go on to this, because I think we all agree that the important thing is to be honest. But while I was working on my book, I came across this book. Let's see, which is really interesting, and it talks about astronomers producing images, and I quoted in the book and in my book, and it's quite interesting, and of course it's a fascinating topic and not an easy one. So I'll leave it at that.
Yeah, I just wanted to make a really quick comment about the nature of photography and the history of photography. I don't know if people know very much about the beginnings of photography, but in the beginning, they were more or less, maybe more or less faithful to reality, but then it became a challenge between looking at painting and looking at photography, right? And I think, this practice of pasting images of the moon into landscape, you have to kind of blame popular culture for that, because if you look at any kind of photography magazine, they often talk about, oh, I shot this with this long telephoto lens and I embedded it into this landscape. And of course, there's this obvious exaggeration of the size of the moon, et cetera, placement, where it's not even possible, right? But there's the challenge, right? There goes the rub. There's the challenge between scientific rendition and artistic rendition.
Yep, absolutely. I just wanted to give a couple of examples of my work and the astrophotographers in our group that may raise some more questions. So this is a total solar eclipse I took photographed in 2016, and there's 3 versions of the image here. This image here is pretty well a raw image that came out of the camera. This is just using a white solar filter. This is no enhanced filters of any kind. This one here was actually an early attempt at doing high definition combinations, you might say. So you take several photographs of the same object as closely as together as possible, and then you combine them. And the idea here is to take the good parts of each of the images that contribute to the best detail, and then layer them all together and produce a resultant image. And it's not great as far as HDR, high dynamic range photos of today are, but that was a few years ago, and it was done more or less manually. You can see I brought out a dust mote very nicely in here from my optics, or it might be some salt spray, who knows. Anyway, I fixed that in this image because this image was, I took it a little bit further and I used some split toning and some tone curves on this one and assigned some false color. So now you can see the beads that are red, normally red here, are now cyan color on here. But they are a lot easier to see. And in this image, I've managed to get a lot more visual detail, I suppose you'd call it. I don't know. I mean, this image has it, but I like this image. I actually like this image better, but that's just me. Some people like a pink and orange eclipse sun, and some people wouldn't. Whatever. So this is my interpretation of basically the experience. And another one I did was using hydrogen alpha filter quite a long time ago at the Island Star Party. I have a Hugh-Tech solar scope, which has a fancy filter on the front. So this is the way it looked through the eyepiece, more or less. And this is a raw image. You can see you've got the flaws in there. This is a very simple processing of the image. Basically, all I did was enhance the contrast and lower the exposure a bit, just to give a bit more detail on the prominence and the surface of the sun. And then I popped it into Photoshop and I applied a second derivative function called Sobel on the image, and I got this. So this basically takes edge detection about as far as it'll go with this particular image, because the image is quite soft. It's not even in great focus. But once you run this kind of a filter on it, you get a lot of useful detail there that you wouldn't normally see, especially in this original image. And you can barely see this festoon. Over here, you can see the festoon. You can see there's actually two bursts here in it, and you're getting lots of surface detail as well, and the perturbations along the transition from the surface to space. So it's a very interesting image and detail you would miss otherwise, but it's not a natural image. Obviously,
So Joe,
it's false color and processed.
So Joe, your middle image is pretty standard from the point of view of solar imagery. So
Yeah.
I think most people see them that way. And in fact, people often ask, well, is that real? And I said, well, I think Dave Payne asked me this. I said, they're always done separately. The central part of the solar image is always done separately from the prominences. It's just the way they're done.
That's right. You have to keep in mind the hydrogen alpha filter for the sun yields a completely red image. There's nothing but red there by definition. So you have to do something with it. Unless you like red images. So there you go. Now let's carry on to someone else's work. Oh, sorry, any other comments?
Well,
Discussion?
I was just going to say, working with seismic, looking at what's underground by shooting sound waves, the results were often shown in color because you want to communicate them. Well, sound doesn't have color, but everyone realizes you're not looking at it for the color. You're just using color to convey a message.
Exactly.
And see clearly and understand what's going on better.
That's right. And you're being honest about it. You're telling everyone up front exactly what they're looking at and how it was done. So let's go to Dave's images.
Those ones are for sure fake, I can tell you.
I can't draw that well.
But that came up really quick, bro.
I don't have enough time left to draw something like that. My God. So before the meeting started, I invited Dave to jump in here. I included his rather thorough explanation of what each image represents. And I picked it out because the left description on the left side said human eyes. And so I thought, aha, we're going to talk about this one too.
Yeah.
The one on the right, as far as I know, Dave will jump in, I'm sure, is sort of a Hubble palette. Not really, but it's sort of a Hubble palette.
It's the Hubble palette in terms of SHO, that order, in terms of what's used for red, green, and blue. Normally, all the green is taken out of a Hubble palette, but I left it in there. And if you're using the color to represent where the light is coming from, then in terms of what ions or atoms that light is coming from, then as long as you know that, well, that's an accurate image. It's not less accurate than the one on the left, even though the one on the left is more like how you would perceive it. But in reality, this was an image that was integrated over a few nights of exposure. So when you're looking at something in Star Trek and you pull up to this thing, you say, oh, isn't that cool? Your eyes don't integrate over, 12 hours of exposure time. So you really wouldn't see that anyways.
No, and in fact, I think I've read somewhere that the closer you get to a nebula, the less you can see it. You almost have to be far away in order to be able to see it, because it's too spread out and it becomes fainter and fainter the closer you get.
Yeah.
And so,
You know, the way I would like to describe these images is that they're basically visualizations. Now, I say that for a reason, because in data science, we use visualization. It could be like bar chart, could be special kind of diagram. It could be color, right? We could use color to sort of denote different things. So I think nobody would think of this as being, quote, reality, right? At least I wouldn't. Given those parameters, I wouldn't think of it that way.
I mean, the brightness is real. The brightness is
Luminosity, yeah.
facing stars that are lighting them up. The darkness is facing away from the stars, or between us and the stars. But is one more real than the other? I don't think you'd say that.
I think it's like all visualizations that are designed to give insight.
Well, as somebody who only looks at things, the one on the left is more real. Because in order to see, is it IC 410 or 405? Whichever one. Yeah, 410. You have to use a hydrogen beta filter to see it. And that's red. Right?
But it's obviously still within your eyes.
But you see it as
sensitivity,
white.
Right? Exactly. But your eye is still sensitive to that wavelength, though, right? So you are, quote, seeing it.
Yeah. Well, you're excluding the others.
Right. You're just being selective.
So you're probably seeing it with scotopic vision rather than photopic.
Yeah, you're probably activating a different part of the eye.
Well, the problem with the one on the right is it's taking SHO data. S data is red. H data is also red. O data is bluey green.
Yeah.
So, if you're to make it those colors, well, now your S data will get all mixed up with your H data.
Yeah, you wouldn't see the differentiation.
You really only see two colors, and it wouldn't be as interesting or wouldn't convey as much information.
That's right. Speaking of information, Ken McGill used the StarNet function in PixInsight to erase all the stars from this famous nebula we've all looked at. And, you know, is that okay or not? I mean, I kind of like stars, but I have to admit, the one on the right allows me to concentrate more on the nebula and see some detail, even though the detail is identical in both images. Nebulous data is the same in both images. When you take the distraction of the stars out, it's kind of it's a different experience, especially the wispy stuff off to the left there, which gets lost in the stars. Now, we've discussed this endlessly in the astrophoto sig, but it'd be interesting to hear other people's reaction to a starless image.
Actually, I'd be interested to hear from people that don't understand how it's done. In other words, just purely figure out what people are perceiving when they look at something.
Yeah, I'm deliberately ignoring all the technical aspects of these images and just concentrating on the feelings and what people actually think about them. Because if we start talking about StarNet and PixInsight and settings, we're going to lose everybody.
The one on the right is definitely moodier, right? Like it invokes a mood.
Yeah.
Emotions way more than the one on the left.
My question is it doing a good job? Because like when there's a star right in the middle of the nebulosity, if you blow it up, can you see that it's doing a good job? And there's certainly when there's no nebulosity, then, you know, it just wipes them out. But what's happening where it's busy?
Exactly. Well, you're losing context is the big problem.
Yeah.
When you erase all the stars, and never mind how it's done. Yeah, you can't see this bright star up here anymore, so there's no reference.
Yeah, in actual fact, the nebula could be the result of a star, right? That's present in the star field, but you wouldn't see that.
Yeah. No more reaction. Okay, let's move on.
The image on the right shows a little more depth to it.
Yeah, it's floating, isn't it?
Yeah,
floating in space. Yeah.
I find it interesting that you all prefer the one on the right, because I much prefer the one on the left because it has more context, and to my eye, it's actually clearer.
Yeah, I like the one on the left as well, just for the record.
Yeah, I like the one on the left too. I just think the one on the right invokes more mood.
Does, yeah.
I like them both.
Yeah, I would tend to agree with Ken. I like seeing variation. If you look at artwork, if you look at the work of a lot of artists, when they reveal their process, when you see their works in progress, you'll see they do variation. And for me, this kind of stuff is just like variation.
Yeah, and to Ken's credit, of course, he posted both of these images on his online gallery, so you can flip back and forth between them. The next one is interesting. The Cave Nebula data was acquired by Gary Sedun, but this processing that you see on here was done by John McDonald. He noodled around a lot with this data. Or sorry, Dave Payne, excuse me. This is Dave Payne's image or imagery.
It is.
Yeah.
I didn't recognize
it. Yeah.
Neither did I. I said
there's a lot of versions on here to look at. Yeah, no, Dave Payne's image. Excuse me. So the top left image, of course, is the one that sort of meets everyone's expectations because it has lots of stars and it has lots of colors, and they sort of are what we're expecting. The other images are interesting, but they're quite bizarre, some of them. And in some cases, a lot of the data that Dave acquired is not used. So maybe John would like to talk about this, or Dave, I don't know which. Because the top left one is just red, green, blue, and luminance. Luminance is just white light. The other ones are all different.
Well, Dave might like to talk about the acquiring the images. I just had some fun playing with them. And one of the things I was sort of interested in, Juan Perez, who is sort of one of the gurus at PixInsight, he's produced this formula for using narrowband images to get something close to what RGB images, what the eye would normally see. To me, it doesn't look very close to what you get with the RGBL images, but it's interesting. And the other ones, I was just seeing how many different kinds of looks I could get from it. I wasn't doing anything scientific or precise. I was just playing.
It's cool.
Yeah, I like them all. The Perez narrowband, of course, throws away so much data. It kind of looks pathetic, but it's interesting to compare it with the other ones for sure.
I guess the one other comment I'd make is that I heard a workshop by J.N. English, who was the Winnipeg artist and astronomer that helped Hubble develop their famous palette. And she gave reasons why she thinks these colors make more sense. She likes colors that sort of emote the feeling of the temperature that's actually there. And for example, we're aware that blue stars are actually much hotter than red stars, but to our eyes, red looks hotter than blue. So that's one of the reasons they changed the color palette around. But I really think they messed up. I don't like it. I've never liked the Hubble palette. And but I used it here just to see what it would do.
I think that's great having them all side by side.
Yeah, it makes me think of like Andy Warhol.
Yeah.
When he would do prints and he would do them all different, but it was the same print.
Yeah.
With different colors and stuff.
It's very common in art.
Hey, Joe, you should get a Campbell soup can and narrowband, see how it looks.
Right.
Actually, that's a good idea.
Maybe that's a new way to popularize astronomy. I just wanted to cover non-astronomical imagery for the next 3 slides, just to finish off. As most of you probably know, Mauna Loa is erupting right now, and at least for a while, the lava was flowing north towards Saddle Road, and north of Saddle Road is Mauna Kea. Mauna Loa, as it turns out, is the largest shield volcano in the world. So it's a pretty intense thing when it decides to blow, as the saying goes. As I mentioned at the start, I worked with Landsat data for many years when I was in government, and this is something that we could never do with Landsat, which you can now do, which is basically produce more or less a natural color image of the Earth. But they have also superimposed or overlaid the infrared data to show the lava flow itself. So again, this is perfectly acceptable for Landsat data, and it shows the problem that the geologists wanted to portray to the the public agencies involved in protecting the road or getting people to move out of the way if the lava decides to go in a particular direction, which is always a big issue, especially on the Big Island. There's always, you probably saw the news reports of Saddle Road being completely awash in cars, and people are all over the place, camped out watching this lava flow and putting themselves in some danger. But as it turns out, the lava flow has stopped going that way. So there you go. Anyway, Landsat data, as I said, is just a series of sensors floating around up in space, looking at the Earth repeatedly. And it's wonderful data to see the changes in the Earth's environment over time, natural systems over time. Let's go on to the next one. Again, a pretty odd looking photograph, or image, I should say, of Prince William Sound, the Columbia Glacier this is the one in Alaska, not the one in the Canadian Rockies. Columbia Glacier is a huge glacier, and you can see in the inset there a natural color, more or less natural color, aerial image of the same area. You can see the tongue of the glacier here, and you can see the tongue of the glacier right here. What I wanted to talk about here was basically the text here explains that the vegetation is green and the clouds are white, but the open water is dark blue, which is not natural, and also the bedrock is a brown color. So you've seen all the bedrock outcrops here, which are pretty hard to spot, and also you're seeing debris and that sort of thing on the glaciers themselves in the various colors of cyan, the bright cyan color they use. So they're using a thematic mapping, and that's what I was doing in British Columbia for many years, was thematic mapping. And this is the same technique that they use here to make measurements of over time, because that's the big thing with Landsat. It keeps going over and over and over the same spot all the time. So you can actually watch the glacier come and go and the changes in the character of it. But, you know, it's not natural color. No human eye would say that's a natural color photo, whereas here they would be more pleased with this. But there's a lot less information in this image than there is in this image. This image can also be zoomed in. You get all kinds of interesting information about what's happening with the glacier at this confluence, for example. It's a great system. I just wanted to talk about high dynamic range, so I wanted to show you a traditional photograph. This is an aerial photograph I took with my drone just over my house, looking toward the city. And I just wanted to explain for the people who are not really photographers what HDR does. So we take, in this case, 5 frames. You can take 3 frames, 5 frames, whatever you want. You take one frame at what the camera's meter would normally take a photograph using to get the best compromised photograph. So, you know, the sky's a little lighter than you want. There's some blowouts in the cloud. You're really losing a huge amount of detail in these dark trees and these playing fields. And some of the houses in the neighborhood are kind of vanishing into the shadows. But in rapid succession, my drone will actually take 5 photographs at once. One is 1 stop over normal. Another one is 2 stops over normal. And then 1 and 2 stops under normal exposure. And the magic comes in the software, of course, when you combine those into one resultant image. And what the process, in broad terms, what is happening with these apps that do this product is they map all the areas that are properly exposed in each photograph. And then through artificial intelligence, they decide what to put where. And they bring out a lot more detail, for example, in the playing field here. You can now see these row of houses that were in the shadow before because it's using one of these overexposed frames to get that area. The cloud has tremendous detail in it now because, again, they're using an underexposed part of the data from an underexposed frame to create that. The sky is nice and dark blue, of course. And you're getting a lot more detail in the hills in the middle areas. The detail in the hills and the middle areas is probably taken from the properly exposed photograph, the first one. But it's a black box. With apps like this, you never really know what you're getting. All it'll show you is various versions of an HDR, all the way from aggressive to very meek and mild processing, and you can pick the one you like, or you can pick them all. So I just wanted to show you that just so you can get some context about HDR, because the HDR we use in astronomy is the same process that we usually have a little bit more manual control of it. But we do take a variety of exposures and combine them into one resultant image. So I'll leave that there. So here's some questions for people. So what do you think are fake? I mean, are the narrowband images fake? Do you always want to see just red, green, blue, and luminance, the standard stuff that we see every day as we walk around on the sidewalk? Are you in favor of stars or no stars or some stars? I don't know if you noticed John's processing here, but I think you'll see that there's quite a few more stars in the RGBL than there is in some of the other ones. So he's actually filtered out some of those stars. And I know Dave and others in our astrophotography group do the same thing. They will thin out the stars. I mean, is that okay? Another thing that I don't really have any photographs to illustrate, but star colors can now be matched to a spectral standard like the Gaia dataset. And jump in here, Brock or Dave, if I'm misstating something here. But basically, Gaia is a survey, sky survey dataset, and they've taken the spectral signature for each star. So they now know exactly what each star color should be. And there's software out there that will actually change the star colors that are in your images that you've taken to the proper ones. Is that more or less it? You've done this, haven't you, Brock and Dave?
Yes, it is.
Yeah.
Yeah, that's exactly what you do.
Yeah.
It's not just changing the color of the stars, though. It's basically finding the white balance for the entire image, because you're generally things when you're doing your astrophotos, because of the Bayer matrix, you end up with improper mix of the red, blue, and green, and you need to repair it, and you need some reference that tells you what things should be, and it's one of the means of kind of recreating a more realistic white balance is really its
But hold on, isn't that like taking Hubble's rings and putting him onto your picture of Saturn?
You could argue that, but it's
No,
not
you
taking
can't.
their
Randy, you're
stars.
just being a pain.
There are tools in, I believe there's tools in PixInsight that will actually replace all of your stars, with fake stars, and that I think is maybe going too far.
There's a command, like somebody wrote it for that.
Yeah, well, then a lot of these processes now, Randy, are done through machine learning. So when people show images, they will show quote correct images to the program, and then the program eventually learns what it's supposed to be. I don't know how much of that is done inside of the photometric calibration, but things like star elimination is done purely that way. A machine or a program is taught to recognize stars, basically.
I think Brock is right when he talks about the white balance, because they've got two different series with the PixInsight spectrophotometric color calibration system. And they do two linear fits, and they come up with what they figure is optimized. And I played around with it, and what I find is that the picture's a lot blander and not nearly as nice looking as the ones that our guys are doing.
Yeah, I think, you know, there's a line here, of course. Are you creating a pretty picture or an interpretation of the data that you acquired? Or are you doing a scientific study of some kind? And if you're doing a scientific study, you're obviously going to do some data standardization, but it probably would go in a different direction than what we just talked about.
Yeah, and in fact, calibration, even as basic as it is, calibration for science frames are different from calibration for aesthetic frames. They're not the same.
Yeah.
However, PixInsight is very proud of the fact that it doesn't alter any of the data. That's a fundamental feature of the program, so that scientists can actually use PixInsight to do some of their work.
Yeah, but that's really just non-destructive processing, which every app does. Every photo app does the same thing.
True enough, but the Gaia thing, that's also non-destructive. That's actually getting, as Brock says, just simply the white proper color balance. That's all it is.
Yeah. It can be treated as David said, as a calibration process.
Yeah.
As long as you don't replace all the stars.
So the bottom line is, don't believe anything you see.
David, come on. I can believe what you make.
I do remember reading a book about sketching, astronomical sketching, and the necessity for accuracy. And they made it sound like if you don't do everything, you know, as accurately as possible, as faithful to what you're seeing, then you're doing a bad job.
Well, you know, I deliberately chose not to bring up the subject of astronomical sketching in this talk because I didn't want it to go on any longer than it already has.
Mars
because
could
I
end up with
knew
canals.
that would set up a whole new range of issues that we'd have to discuss and pick through. But it's a great subject. I think we should probably tackle it because it's a human interpretation of what you see, putting it on paper rather than recording it using a digital sensor of some kind. Kind of a new twist.
Actually, Joe, I belong to a lot of photography, things, and they say the very same things you've just been saying about this. Every photograph is always just an interpretation of reality adjusted to your preference. So it's all kind of that way.
Yeah,
I think it's absolutely that, which is why I think the average photographer doesn't balk at composites. In fact, even at the origins and the history of photography, people did composites. That's what they did. They were trying to mimic painting.
And also the HDR images actually mimic the eye better than you would think. The reason for HDR is because when you look at a dark spot, your eye actually gets bigger so you can see it. That's it. When you look at a bright spot, the eye gets dimmer, smaller so it can see it. So that's actually, the HDR is actually a lot more the way we see it as opposed to seeing everything at the same level.
Mm-hmm.
Yeah, you're right. I was kind of surprised actually that the Victoria Camera Club, which is quite a traditional organization, now has a section or a group that is concerned with the last bullet that I have on the screen, purely AI generated depictions.
Yeah, wow.
And I put that on there actually because Dennis Crabtree, who, as most people know, is an astronomer from Observatory Hill, has been posting a lot of photos that are completely generated by AI text to art programs on his Facebook page lately. And he's put in astronomical images and arty type images and human interest images and landscapes and you name it. And they're all just something he's written or dictated into these AI driven programs. And it creates an image of some kind. And he has essentially no control over it other than his initial input as to what he gets out of it. So, you know, if that goes into the astrophotography arena, I'm kind of wondering how that'll work out.
It could be
Or
very
how
poorly.
it'll be accepted.
It could be very poorly. Somebody's going to say, see, all Canadian astronomy data is fake. And then we're
Well, again, it comes down to being honest about in your description, right?
will David Crabtree, will he admit that all of his data is fake? I can just see the headlines now.
Yeah. Don't give that story tip to the Times columnist or it'll hit the paper.
That's kind of my point.
They're kind of desperate for news. Anyway, that is my presentation.
Thanks.
It all started with a fake image.
Mm-hmm.
Mostly, well, it's mostly real actually, but he just did a real number on the rings.
Yeah, right.
And but I don't really find this issue that interesting. What I find more interesting is actually what people feel about astronomical images. So there you go. That's my presentation.
Well
Thank
done.
you. So I understood Randy had some things to speak of.
Yes. So first, I guess it's now a couple of weeks since a important member of our community died, Dave Bennett. I did not have the pleasure of working with him, but the tributes have been coming in on the email, and I would really appreciate hearing more about him. I had the opportunity to meet Susan Bennett, I guess it was Thursday. So I'm sorry, I'm blocking on Dave's observing friend, Guy somebody.
Guy Nason.
Guy Nason was his observing partner, and Guy asked me to relieve Susan of that part of the garage. So now I have a whole bunch of fantastic equipment in my basement, and Bruce is going to do an appraisal, and I'm not sure what we're going to do, but there's thousands of dollars of eyepieces there. And I had a nice visit with her. It's funny, one thing I didn't take, but she said it was, there was some audio equipment, and it was from occultation experiments. And Dave, you said that you did an occultation experiment with it.
I did. In fact, I was this afternoon, I was trying to dig out the raw coordinates. I still have the data file myself, but I just can't remember the name of the number of the cord. It was Varsavia, 1263 Varsavia. That's the name of the asteroid. And I remember Dave picking out the star field. And I could have done it myself as well, but I was really worried that we were going to pick the wrong star, right? But like I mentioned in my comment, the star just very routinely just blinked out perfectly for like 2.3 seconds or something like that. And I do thank David for that, because he did do the research and the star hopping guide to get there. So it was wonderful. It was actually, I've done sort of occultations casually, but I've never done one as part of a very large group. So this particular occultation was done by observers down in California, up even beyond Victoria, actually up the island. but I think we're cord number 9 or something like that. So it's named Bennett and Lee. So we got our cord on the Varsavia asteroid, which kind of looks like a potato. Very cool.
Very good.
Yeah, I remember the Varsavia occultation because I was new to the group and I really thought this was kind of a weird thing that people were doing. So I had to go and see how it was done. So that was one of my first involvements in the group, as it turned out.
Yeah, there was a lot of people that sort of participated, and it was great that everybody did in their own way. But I think it was actually Dave that actually bugged me about doing it. And I said, well, I've got the camera. If you supply the telescope, you find the star and we'll do it.
There's a shortwave radio in that kit also.
There is. Yeah, we used a shortwave radio as well to get the timing, because basically what happens is I used a video recorder, which has an audio track. And basically we set the shortwave at WWV somewhere down in Fort Collins for the time signal. And I actually took it apart inside of a video editor to find the exact time when the star disappears. And then I mark it against whatever time marker there is. And then I count the number of marks before the star reappears. That's how you determine the very accurate timing of it. I hope to revitalize that if anybody's game to do that.
Now we can do it with a little GPS chip instead.
We can. Yes, we can.
Well, that's a lot simpler.
Yeah.
So does anybody have recall of doing outreach with them? I mean, Susan called out in particular to say hello to
Well,
Sid.
I think I will mention a few things. Lori's not here. Lori is probably most familiar with Dave's time up on the hill on Saturday nights, but I'll just mention this. There was certainly a group of us maybe like 15, 20 years ago that would be consistently up on the hill doing outreach on the parking lot. Now, that hasn't been the case with the pandemic the last couple of years, but Dave was definitely a fixture, along with Roy Watson, who has also passed now as well. But yeah, they were often. I remember Dave having his kind of unique looking mount. He has an Ioptron cube mount.
Yes, that's in my basement.
Okay,
What
so
is it?
it's a cube mount. It's just like a regular mount. I guess it's an alt-azimuth mount. Yeah. So he paired that with quite a long focal length refractor. It's a deep blue, I think, Skywatcher refractor.
Yeah.
It's probably like 100 millimeters or something like that.
I think it's a 5-inch.
Maybe a 5. I don't know. I don't remember exactly. But I remember he used to put this.
Skywatcher 120 millimeter.
There you go.
1000.
There you go. There you go. And there, actually, that's the photo with the Ioptron mount in it. Yeah, that's the one. That's the little cube.
Yeah, there's a.
And in fact,
a memorial photo collection on our photo hosting website for those who are interested.
In fact, that was Dave's spot, that corner of the lot.
Those mounts work quite well. You can mount a scope on either end of them, so you can have 2 different scopes.
Yeah.
It was we got one with part of the donation at Pearson. So you can put like 2 different solar scopes on it, and then you can watch at the same time with 2 different scopes, like a white light and a hydrogen alpha.
Yeah. So the other thing I would add is I know David quite well as Roy, because we used to work for the same IT group in government. So that's where I know them from.
There's the crew.
Yeah, there's Roy, who's no longer with us, but that's Roy and David.
That's Matt's dad.
That's right.
Yeah.
That's right.
Yeah, Matt,
Yeah, Roy,
Matt left a memory on the, I posted to the website as well.
yeah, Roy was our MVS expert in government.
Yeah, and Dave used to do some of the school events. I can remember doing a couple with him, and so he and Sid knew each other quite well. I can remember Dave and Sid and I think went out to Salt Spring Island to do a thing at the school there. So
Yeah, I think about 10 years ago, groups of us went out
that's
to
about right. Yeah.
different islands. Yeah, for Parks
Yeah.
Canada, I think. Parks Canada. Yeah.
Yeah. So yeah, when you first met him, you might find him kind of a little dour, but he had a pretty good sense of humor, and he was fun to be with.
He sure was.
Thank you very much, buddy. And then the other thing, I hope everybody has received an email that I sent out on Saturday. Everybody's favorite subject, our Constitution and bylaws. First of all, can people just wave their hands? Did you actually receive an email from me? Oh, good. So the request is first, I read it, and if you can actually stand it, please do take a look at what we're proposing. Make sure that it fits your vision of what this club is. Like, we're here for fun. We're here to enjoy the sky together, but we have responsibilities, we have property, and so we do have to be run responsibly. So take a look at it and get comments in. We've given you more than a month because of the holidays. So it's January 15th is the deadline, and I'll send out a reminder in early January. And then we will try to reconcile the various comments that we receive. And then when we call the special general meeting, then it will be fixed. We can't change what we're going to vote on a couple of weeks after the announcement of the special general meeting. We can't then do a bait and switch at that point. This is the time to make suggestions, because other than a punctuation error or something, what we put in the SGM announcement then is what we're going to vote on. And the big request is, please come to the special general meeting. We need quorum in order to have a valid vote, and then it will be by 2/3 vote. And then we will know whether we're using our current bylaws or these new bylaws to run our next election for our annual general meeting, which will be late February, early March. Let's see how things go. Okay, so a group of us have taken it very seriously. And I would like it if the general membership, made sure that this fits what you are hoping for this group. I love this community. I think we've been at it since 1914, and it's just, we have to update these bylaws. They were obsolete. So that's my request. Thank you, Brock.
Randy. I guess it's coming up on 9, so we probably
Brock, I just have one last
one last thing.
announcement. Okay. There is a SIG this week. Okay. I don't know if the notice has gone out yet, but this week is the Makers SIG. So all things that we take apart, that we repair and want to construct. So if anybody is not part of the makers group and you want to be, you want to attend this Thursday at 7:30, just send me an email note to david@victoria.rasc.ca. Great, thanks.
Thank you. Anybody have anything else quick before we wrap?
Brian's got his hand.
Oh, Brian, did you
Yeah,
have?
I didn't hear anyone mention the lunar occultation of Mars.
Oh,
November 7th. Did people miss it, or was it?
It was a bit of a washout, but the diehards were out there, and
Nathan and I both saw it in Fairfield. I think.
Okay.
I think our cloud cover was not as bad as further north.
Yeah, and I managed to get a frame. I think everybody's seen the image already. It's not amazing, but you can see Mars. You can see Mars.
Yeah, no, I did capture the as the moon passed in front, but I couldn't catch the exit. It got too cloudy. But I
couldn't either.
Couple pictures on Zenfolia.
Yeah. So the one thing I will say, I think the visual people win this time because I really liked the view through my refractor. It was really tough photographing it, just really tough. I was just hoping for the best, basically, for the photographs, but I had some really nice views through the refractor. Did you as well, Brian? Through your telescope?
Yeah. Well, it was cloudy, but able to see clearly that the Mars was a disc and orange, and set it up at the top of the driveway so the neighbors with their kids were able to come and capture that as well. Because I put the camera on the mounted the mobile phone camera on the lens so they could see the image without having to get right up to the eyepiece.
Oh, good. Doing a little bit of EAA.
Yeah, that's right. Front yard extension. Yeah.
On Enkin's daily moon this week, I've been presenting pictures of it. So if you want to take a look at a bunch of really good pictures from all over the world. Well, it was from Europe and North America. Some people just did a fantastic job.
Did anybody catch the Griffith Observatory broadcast? That's the one I watched, and it was kind of cool.
I looked at it, Griffin, but I saw it with my binoculars.
And you could see it.
I could see it, but I didn't saw it disappeared. I wanted to get my big binoculars and went back, and then I couldn't find it.
Yeah.
So with that close.
Now, when the meeting started, somebody said they wanted me to say something about Artemis. I don't know if that.
Oh.
Well, we're gonna have to do it quick, Chris.
Yeah.
Okay.
It went splash.
It did.
And it didn't hit anybody.
It did. So you can see here, a few days ago, it made its second really close pass to the moon. This time to the far side, and it had sent back these spectacular pictures of both the Earth and the moon. And yesterday, it splashed down in the Pacific after 26 days in space. So over the next little while, they'll crack open the hatch and take a look at the equipment that was inside. Early in the new year, they will be announcing the crew of the next Artemis, which will include a Canadian. And I want to, let's see, where is it? Something else that I'm watching right now. Can you see the motion there?
Mm-hmm.
This is, if we're had all this fancy equipment 50 years ago and we're watching live Apollo 17, this is what we'd be seeing. This is the second EVA 50 years ago, this moment, about half an hour ago, they were at Shorty Crater and discovered the famous orange soil. And so I've been following this all week, and there's another a few more hours of EVA tonight, and then there's the third EVA tomorrow. and that was the last time humans walked on the moon. So I'll put that that website on the chat. And so
Chris?
That's very, very cool that you got the exact timing.
yes, so this website is designed so you can do that. But if you wanna watch this EVA in a February afternoon, you can do that, or bits and bytes here and there. And oh, I've got one more thing. Just to relate to our discussion from Joe. This is one of the most famous pictures ever taken in the history of spaceflight, and it is usually presented doctored. This version is not doctored. Can you tell me why? How is it different from what you usually see?
Is it
There's
cropped?
stuff in the front.
Is it cropped, Chris, or?
Well,
Is it-
it's not cropped, and that's the point, because you can see right at the top, he cut it quite close. Neil Armstrong took this picture. He cut it quite close,
Yeah.
and so usually it's presented with a little bit of black above the cauldron.
It's a square Hasselblad frame, right? It's a square
Yes.
frame. Yeah.
And actually, there is something missing there, because there should be an antenna sticking out of the top of this, the portable life support system, which never appears in the pictures you see in Life magazine or what have you.
So they edited it out then, Chris, or?
No, they added a bit of black to the top.
Oh, just to give it some height, right?
Yeah,
Some blackness above.
they uncropped it.
Right.
Right.
And then they never drew an antenna in.
Yeah.
That's right.
Chris,
So
Yeah,
that's
they
all
weren't-
I have to say.
They weren't trying to hide anything, maybe.
Yeah.
Wasn't real.
Chris, I'm wondering if you could say anything about the reentry that Artemis used, because it sounded like it was a slightly different method than previously used.
Well, I think a lot of it was kind of a different path, because it sort of it kind of whipped over the South Pole and then came up the other side, and of course landed just off of San Diego. But it had a bit of a skip maneuver during that reentry to kind of bleed off some of the velocity, because it was going at nearly 25,000 miles an hour when it first touched the atmosphere, which is a lot faster than, say, something from Earth orbit is going when it comes back. So but they did have some skip reentries in Apollo. I think actually Apollo 11 had a skip reentry because there was a storm where we were supposed to land, so they actually put a little skip into it, so it went about 500 miles downrange from the original landing point, and there was less problems. So anyway, but there were the trajectory of Artemis throughout its flight was quite different from Apollo, because usually Apollo you're orbiting very close to the moon, and Artemis spent most of its time kind of distant from the Earth, but also distant from the moon. And there's only at kind of 2 points in the missions where it made close passes to the moon.
I see. Okay, thank you.
Okay.
Did people check out Bob McDonald's overview of the Artemis mission during the DAO star party in the summer? It was I'll post it in YouTube. He was quite critical of it. It was,
Yes, he called it the Frankenstein rocket because
Yeah.
it was actually made from parts of things, a lot
Yeah,
of
yeah.
parts
Well,
and things
challenge-
like that.
Space shuttle parts and how it was basically the first two missions as part of the Artemis are actually just help keep contractors in all the different states busy, where the actual SpaceX is the rocket that'll deliver the astronauts to the surface of the moon. Anyway, I'll share a link to that in the YouTube to that, because that's really interesting.
Yes, it was a good talk.
Yeah.
Thanks.
It was a maker's project.
Yeah. Is that what you're doing on the SIG meeting?
I'll surprise you, Brock.
Okay, I'll be surprised. Okay, good meeting. Thanks,
Bye,
everybody. I
everybody.
think we're getting overtime here. Have a good night.
Good night.
Thanks, Brooke.
Good night. Oh, and thanks to Alex for setting up this room.
Welcome.
So.